systems.
Test 1, 2, 3. Yes, this works. Amazing. Good morning. There were some people drinking vodka last night. I saw a few of you. Good to have you here. First question for y'all. Who was at the keynote just before this one? So I should say welcome, certified, whatever, Flow developers. We need to talk about a word. And this is the word I want to talk about. Hence my reference to the keynote. Because I just learned this is not DevSecOps, it's Sec, DevOps, Sec, Dop, whatever. But still, DevSecOps. Who likes this word? I just want to see hands. 2. Great. The first time I saw this word, and I appreciate that you like it though, but the first time I saw this word, it was like, really? Yet another buzzword? Let's put it next to machine learning and blockchain, and we have a full buzzword bingo card. But hey, I work for a security company, so this was the marketing term. But if you look at this term, DevSecOps, and you look at what we're actually doing there, it kind of makes sense. Who practices DevOps, or to a certain extent tries to practice DevOps? So the rest is still in the waterfall? Great. Anyhow, what we try to do with DevOps, or however you might call it, or Ops Dev, or, well, just learned a few things in the keynote, we try to tear down that silo between developers and operations, glue them together so they work better and we can deliver better, faster, and stronger. If your team is developing software, who's developing software? All of you, thank God. I thought I had managers in the room. But if your team is developing software, and to a certain extent, they are also responsible for putting it into production, and if you get called at 3 a.m. in the morning because your server is down, or the next morning, if you're lucky, then you're doing DevOps. Basically, you owning what you create. It's not, works on my machine, throw it over the wall, now it's your problem. That's what we did before, with the silo dev and ops. However, if we look at security, this is still the case, because I'm a developer. I don't know crap about security. We need to change this, and that's why this talk is about. We need to focus on security as a first-class citizen, because nowadays we work in the cloud, so that means we think about scalability and maintainability. 10 years ago, the cloud was just a thing in the sky. Now it's something with computers. So we need to think differently. Hence, DevSecOps, we need to embed security in our whole mindset. Still, I believe it's kind of a buzzword, though. All right, this is me. I'm Brian. They told me once that I was a Java champion. I still don't know why. Do something in the community, blah, 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 blah. I work for a developer advocate. I work as a developer advocate for Sneak, which basically means I code less and send more emails. But we're trying to solve something with that whole DevSecOps mindset. So let's go into that. What are the actual problems we need to solve? Because we can create a term, but if we're not solving anything, why the hell are we doing this? Well, first of all, let me take you to my own journey, say from 15 years ago. I worked for, I'm based in the Netherlands, and I worked for one of the major government agencies. And at that point, we delivered 3 times a year, which is marvelous, because then I can say it works on my machine, throw it over the wall to the ops guys, test it, you've got plenty of time to do so, and if it doesn't work, they come back to me, I fix something, whatever, works. But if we look nowadays, we tend to speed up these things. And I worked at a company before I joined Sneak, and we delivered 3 times a day. Well, try to do a pen test if you deliver 3 times a day to production. It's not possible anymore. So we need to change that mindset, because if we want to deliver more, which is good because we want to be better, faster, and stronger than our competitors, because if we do so and we have that feature out, we might have a positive advantage. However, security was not on our mindset. And yes, I went into that whole cycle of being breached once. But the problem is, because we think, and you probably know this, like you have that product manager or program manager or whatever you name that role, breathing down your neck that you need to get that feature out today. Okay, tomorrow morning. Point is, if you do so, you probably take shortcuts, or we create a lot of technical debt because we say, yes, of course we can. Might be quick and dirty, But we can. And that's all what the business cares about in the end. However, if the lack of security is there during the whole life cycle, we might be getting into a problem later on because, face it, security is still siloed. In many companies, and probably yours as well, you have a security team, siloed, working for a bunch of engineering teams. For who is that the case? A bunch of you. So the rest of them have security engineers in their team. If so, that is amazing. But if not, you see that you have one core security team and the amount of engineering teams is scaling tremendously. But still with one security team. How do you scale security in that case? In the end, we need to play along. We need to make sure that we adapt security as well. So that it's not, think about it. If I have a security engineer, and every 3 weeks I build my new feature and I have the end of my sprint or my cycle, and I come up and I say I want to release it. And then the folks at security say, nope, because they found something. Well, I can handle that once or twice, but if it's going continuously like that, we get into friction. We get into trouble because they think I'm a cowboy, and I think from them they're just saying no because they hate me. But in the end, we need to play along because we don't want our customer data to be compromised. All right. The thing is, this is a nice story, but how bad is that situation actually? Well, if we think about security as a developer, I mean, who's a Java developer here? Who's a JavaScript developer? Who's still asleep? Good for you. We think about our own code. That is the first thing we think about, like the code we write and we put on Git, GitHub, GitLab, whatever. We put into our repository. However, that code is only 10 or to 20% of the code that you put into production. However, that code is also very important because that is the differentiator between whatever the Spring Framework does and whatever your application does. So the business logic, the thing that makes the difference between a generic program and whatever you make for your customer or your company. So say I make a Spring Boot application, like many of us do in the Java world. First thing I do is I create a controller. This is my nice little controller, doesn't do a lot. And what I did, I created my first security mistake. And you probably will find this with code reviews. So let's do a live code review. What's the problem? This is the problem. One of my request parameters is a string. And without doing any form of validation or sanitization, I'm giving it back right away to a response writer. So this is typically a cross-site scripting exercise. Because if I do something like this JavaScript will get executed. And well, okay, the alert is just fun. But if I can do this, I can actually execute code and might be able to go into the cookies or your session ID, depending on if you configured everything correctly, steal that, get it over to another website, and pretend to be you. Just making up something now. But face it, this one is an easy one, right? And probably with code reviews or pair programming, we can probably find it. Who does code reviews? The rest does pair programming. Thank you. So this is the problem we created. And cross-site scripting is not only in the URL, we can do it in different ways, like the scripts, the mouse overs, the image tags. There are different ways to do these kind of things. So let's go into a live example. I've got an application over here, and let's log in. Of course, my password is admin, because I work at a security company. No, don't save it. Don't do this. Please don't. My boss will be angry. So, well, first thing you see over here is if I go, basically this is the problem I showed you. In the header you see that the parameter over here is sent and is printed over here. So if I do something like this, you will see the alert will pump up. And I can do all sorts of things. Well, okay, that's fine. We found this. We do code reviews. No biggie. Another thing over here, I can search. And this already gives a bit away what the problem over here is. What is the typical problem over here? Sorry, again. SQL injection, absolutely. Because if I do something like this, And basically what I do, I just close the query and update it to a new one and just try to work it. Now try to update everybody's last name, and if I search again, you will see that everybody's last name is evil because SQL injection. You might have found that as well. So let's go into the code, what is actually happening. So what I did is I inserted a tool, and as I said to you, I work for a security company, so we also provide tooling. One of the things, the SQL injection and the cross-site scripting was easily found by just scanning my code. It says cross-site scripting. That is over here on user controller line 38, which makes a lot of sense because that's basically what I just showed you. Over here, have the parameter, and that parameter is printed out here. So easy. I can fix that to see what kind of things how can I fix that? Well, for instance, by using escape HTML. Makes sense. The SQL injection was also easy to find, and you probably have found that already yourself. It starts at the user controller on line 60, ends up in the search repository, and yep, technically we have a SQL injection here because the parameter, without any sanitization, or in this case, query parameterization, was just concatenated to the query. Cool. But what about this one? It says I have a path traversal issue at line 69. Okay, on my file controller, let's see what it does. And let me enlarge this code a bit to just show you what the problem is. So what I'm trying to do over here is I'm trying to upload a file. And this is a multi-part file. Multi-part file is nothing more than a object representation of a post request with the file binary in it. What I'm doing here is I'm trying to upload the file to the upload folder / and I use the file.get original name. Well, it says I have a path traversal issue here because the problem is if I look over here, it might be the path might be something like if I just alter the post request like /////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// or outside of my scope of my application. And I found this one while I was writing this demo and was like, fair point. So even though it's 10 to 20%, it would be nice if we catch this thing early. So we might find this as all senior developers and all great experienced developers, but what about your juniors? What about people that come into the industry? If we have things available that can help you fix this problem already while you are coding, that is a big win without doing any sacrifices. So that might be a good thing. But okay, we said it was only 10 to 20% of what we did. And this is visible to all of us. What about the next step? Like, we've got the iceberg, but under the surface, under the water surface, there's pretty much more. We all know that. So the first thing is open source. Who uses libraries or frameworks? Okay, let's do the other way out. Who does just core Java or JavaScript without any libraries? Exactly. 80 to 90% of the code that we put into production is things we inherit, like Spring Boot, Quarkus, Micronaut, or whatever JavaScript framework you might use. And, well, that sometimes can go wrong. For instance, 2017. Who have heard of a company called Equifax? A few. Keep your hands up. Who heard of that company before 2017? Well, so you basically heard of this company because of that hack. That is good marketing, I would say. However, what happened is they were using Apache Struts 2, a vulnerable version of Apache Struts 2 at that point, to build their application. Let's just assume their business logic was spot on, there was no problem in there, but because they used a particular version of that Apache Struts package, well, framework, that does all the big plumbing for them, and that was already in production, and they were focusing on new features, which typically happens, something went wrong. The hack or the problem in Apache Struts 2 was already found in March 2017. 3 months later, in May, Equifax got hacked. They could snoop around for months, and after 75 or 76 days, they discovered that somebody was in. At that point, over 140 million customers were compromised, and up to the day now, it's not even 2.1, it's more, it's $2.2 billion is the generous price that they had to pay to cover all the damage, not including what it does to the brand. But the point is, they were using an outdated version of Apache Struts too, and let me just demo that to you. So I have an application here, and this application runs on Heroku. So hopefully the Wi-Fi gods are with me, and it actually still runs. Looks like it. But I don't have to go into the application. Now, I go, as a real hacker, and I forgot my hoodie this time, go into the terminal, and I will enlarge it for you, and we'll actually show you what we're going to do. So this is what I need to do. This is a header I need to use. And maybe we can, let me just try this. So if I do a curl request to this application using this header, I can do some funny stuff. And the only thing I'm doing is I'm inserting a content type. Who recognizes this content type? Come on. Really? One person, two person? It's an invalid content type. What happens with this particular version of Apache Struts 2, which was the version that Equifax was using, you go into an exceptional flow, and because of that exceptional flow, we were allowed to utilize OGNL, the Object Graph Navigational Language, which basically is an expression language in Apache Struts. In that expression language, with that expression language, I could do certain things, like call certain methods from certain objects, or even worse, I can create new objects. And that is exactly what I do here. So let me put here. New process builder. Fun. I assign it the bash, and I can assign that a arbitrary command. What does it mean? Because I can utilize the expression language, I can open up a new process, and I can basically put in any command that I like. This means an arbitrary code execution, which sounds fun. So let's try that on this Heroku thing. Let's try this one, and I will explain in a second what I'm doing. So I'm using that header I just showed you, and I make a substitution. I switch out the word command for the word env, and env is nothing more than the Linux command to show you your environment variables, right? It says on localhost 8080, but we don't run on localhost, we run on Heroku. So let's try this. So nothing more than a curl get request with a specific header, and let's execute this. And what we see here is that these are the environment variables of this Heroku pod, which means I can actually break in. And if I can call the environment variables, which are not that special, I can also do other things. I can create a file, I can create a script, come back tomorrow, actually execute that script. Good luck you finding out with your post-mortem shizzle to whatever happened. Even worse, I might be able to set up a remote reverse proxy to get into your system. We'll come into that later. But this is basically what happened to Equifax, and just because they were using an outdated version of a particular library or a particular framework. If they would have updated, because the patch was already available since March, even before they got hacked, there wouldn't be any problem. So going back to my slide deck, if this is the application you write, probably this is the code you wrote, because the rest is Spring Boot, everything that is generated for you, and all the things that you bring into implicitly. But we do take good care of that little purple dot in the middle, because we do code reviews or pair programming. But how much do you care about the yellow part? Who has a policy when to integrate a new library in their application? That's not a lot. So everybody can update it. Who gets rid of certain libraries after a certain amount of time because they're not using it anymore? Who actively scans that? There's a couple of them. Thank you. I appreciate that a lot. But a lot of companies don't. I worked for one of the banks, went into their POM file, and saw 3 different XML marshalers. Why in God's name would you have 3 different XML marshalers? Because it grew naturally, and somebody was like, I need to build this, put a new dependency in. And it's unnecessary. And if you're not updating it, it can get worse. So, little exercise. Spring Serverless application. We wrote this a couple of years ago, 222 lines of serverless code. Very bad code because it was demo code, a lot of duplication, etc., etc. 5 direct dependencies. How many dependencies do I have? How many libraries do I have in my jar files and my application? Make up a number. 500, I hear. 1,000. Well, it was 54. Not that bad. But how many lines of code do I actually need to maintain? Because I'm not maintaining my own code, I'm maintaining the application as a team, because we do DevOps. How many lines of code do you think? Just scream. Come on. 20,000. Who says more? 200,000. Well, it was actually 400,000 lines of code. And I have no clue what that code actually does, because I blindly depend on it because, well, Stack Overflow told me so. Anyway, the point is we need to take care of this because the usage of open source is perfectly fine. I'm an open source maintainer as well, and the usage has exploded over the last decade or so. But the bad folks are also looking at that. So if there is a library or a package or a framework that is well used, like by a lot of people, and if there is a problem in there, we have a potential large pool of victims. That's good for me as a potential hacker. So one thing we need to do is we need to update. Some statistics. New packages by ecosystem per year. Well, clearly NPM is the clear winner, and I can make a lot of jokes on that, but I won't this time. We can say something about quality, whatever. Past 2020, they already reached that 1 million mark of the amount of packages. I think in half 2020, there were like 1.3 million or something like that. But if we see that every year new vulnerabilities get identified, and, well, this is still from 2019, I need to update this to the new graphics. But what we see is that in Maven Central, we found a ton of them. And most of them are not in the packages that you actually include, but because a package includes a package, includes a package, and 3 or 4 levels deep, then you have something that might be harmful. And where did we see that lately? Where were all of you on December 10th, 2021? Yeah. At your computer. I was actually packing my bags to go on holiday to a tropical island. Yes, it was pandemic, I know, but it was allowed. And that didn't happen because of this one. The infamous log4j. Basically, what we saw is that 60% of the folks that had the problem with log4j had this dependency as a transitive dependency, not even probably knowing it was log4j. What we also saw is that 70,000 packages at the point of when that breach was found, 70,000 packages within the Java ecosystem at least were infected by it. And within the first 72 hours, an automated amount of 80,000 attacks were made on different kinds of services, and we don't know which one succeeded and which one doesn't. Because people usually not tell you that. Well, who has encountered a problem with log4j? Actually getting breached? Wow. Or you just were like making sure that it doesn't happen again and fixing it. Well, then you probably know this thing. I will briefly explain to you how the log4j problem, the initial problem was. So say we have an application, and this is my application. Oh, let's do that again. And say I know I can log something. I know for sure that something is logged because, for instance, I create an error. And a good thing is, say I am trying to log in with a wrong username or password, then there probably will be a log line like user X tries to log in, or a login attempt failed, something like that. So if I do that, and instead of the username, and if I know the username is printed, I do this line. It's basically a JNDI lookup, and I can combine a JNDI lookup for whatever reason with an LDAP request. So I call the LDAP server, and that is actually a server that I own. So the LDAP server I own, so with the JNDI lookup, I go to my evil.com website, and what I do, I give back a reference to a precompiled class. That is on an HTTP server in this case, for instance, and that I also own. So giving that response, it's evil.class, And at evil.class, if I construct it in the right way, I can actually execute arbitrary code. So the point is, this was already in Log4j since 2013, but nobody noticed. Say my evil class is something like this. I can execute arbitrary code, and basically what I'm doing here, I'm just opening a calculator. It's nothing really special, but I will actually demo it to you. So, having this application, please log out, and what I will show you is yes. I'm running on a Java version 1.8. I think it's 100. Yes, it's 111. So it's a very old Java 8 version. But what I can do is, if I log in with something that is fake, you will see a log line at the end will be this, username. So I have my LDAP server spun up and the HTTP server spun up on my local machine. I have that precompiled evil class I just showed you on the slides. So by just doing the arbitrary code execution or calling that command, and that's on my localhost /evil, doing any given password, and if I sign up, what we'll see is that the calculator starts up. Okay, fun, now I can calculate things. Boo-hoo. The thing is that in the beginning we thought, and this is a blog post that we wrote at Sneak, that we thought that if you were running on an old version of Java, that was the only problem. If you're on newer builds, because in the older builds there was this trust URL code base. Parameter was set to true by default. On newer versions it was set to false. Basically, on the older versions we said whatever is on that remote system, we trust blindly. Not really a good practice. But in newer versions this was not the case. So we thought if you're on the newer version, you're done. Well, actually this is not the case, because this is not so much an arbitrary code execution problem. This is a deserialization problem. Who knows what a deserialization gadget is? Okay, briefly explain it to you. What we can do if this code, like that class that I'm using, if that already is on your class path, then I can still reference it. I'm not trusting the remote code, but if I already have it on my class path, and think about it. Every library that you have on your class path, potentially, can be loaded into memory, even though it's not directly hidden or directly hit. So that means if there is already a deserialization chain possible, we can use that to basically do an arbitrary serialization execution with arbitrary code in your system as well. So let me show you that. First of all, cut down this one and spin up my Docker container. Yada yada will spin up, good. Instead of going into the class that I showed you, this was the original class, the open calculator, but I'm doing something different now. I know that in this application, because hey, it's open source and I wrote it, there is an outdated library of Apache Commons 3.1, which has a known deserialization chain. That means if I create such a chain in the body, in the end I can call the runtime again. I'll look for that code, basically grabbed it off the internet, and put that in my LDAP server. And what I'm doing here is I'm using the transformers and the invoke transformers from Apache Commons 3.1, which I know is in that application because, hey, I published it on GitHub. And again, I'm getting the runtime. And I'm invoking the runtime. And I'm not giving it the actual class. I'm just giving it that Java serialized data, sending it back to you. But instead of doing that with opening my calculator again, I do this. I try to set up a reverse proxy. So basically trying to hack my Docker container from a remote place. Let's try if that works. So over here, let's close this one. And let's reload this. What we see here is that Java version is, no, this is not the right Java version. I think this Java version is 1.3. Over here. 1.8.322, basically the latest Java 8 version. And many of the folks are still on Java 8. I have my server still running, and what I'm now doing is over here I'm launching Netcat on port 9001. So I'm now listening to port 9001 if somebody connects to that. Doing something similar, but now not connecting to my local host, but from my Docker container back to the host machine. Of course, I can do this to a remote machine, but if I do that, probably my Heroku application will get suspended or something like that. Trying to do this, giving the password, putting in that serialized data, sign on, and now I have access to that machine. Who am I? I am root. So basically, I now have a full remote terminal to my expense. So some people say, yeah, Java serialization, and we don't use Java serialization, so we're not in trouble. Well, if there is a possible chain with all these libraries that you're using, I can use log4j to actually execute that whole thing. So even if you're on newer versions of Java, you are still vulnerable. That's the main point. So how about vulnerabilities? How do you find out about vulnerabilities? Unfortunately, 27% of the folks say, I don't think I will ever. And this is the million-dollar question. Who is actually responsible for it? Developers, the security team, operations? Well, in fact, it's a shared responsibility. If you look at the application, so your code and the open source libraries, most people think it's developers need to take their fair share. And that's for a good reason. Think about it. We want autonomy. So we want to make sure that we can solve the things in the way that we like, with whatever code we want to use, whatever library we want to use. And that's for a good reason, because we are the specialists. However, we nowadays think about scalability and maintainability, but security should be in that line of thinking as well. Is that library, is that secure? Aren't there any known vulnerabilities with that version? Also with your code, am I not actually opening it up to whoever that is? For instance, back to that code review thing. Who do you think should review your code? Is that the junior in your team? Just 2 minutes before the sprint, because then I can just ship it? I worked 3 weeks on it. Hey, junior, 20 minutes is enough, right? Probably not. But think about it. This is what happens in most companies. So think about this more consciously. We talked about code, we talked about open source, but then there's the next layer. We probably don't just ship our jar or our application just, here, have it, ship it into production, Mr. Operator. No, we now have to solve it with, for instance, a container. What is the first thing you do if we talk about Docker containers in a Docker container? What is the first line in a Docker file? From, exactly. From Ubuntu, or from Debian, or from Maven, JDK, OpenJDK 3, whatever. We downloaded the 10 most commonly used Docker images and scanned them for vulnerabilities in their operating system. Again, I have to hold myself back not to make fun of Node. Anyway, what we see is that every single one has vulnerabilities, and then you can say like, yeah, whatever. All these vulnerabilities were traced back to the operating system. For instance, the Node latest was, at the point of testing, was based on a full Debian distribution. Makes me think, like, do I actually need a full Debian distribution to just ship my tiny microservice? Probably not. But if you look at that, it ships with a ton of binaries and a ton of applications in that operating system because it's full-blown. And I don't need that, but it can harm me. And if you say, like, there's no direct path to it, probably not. But most security issues are not a direct hit. It is, I can do something, and I connect that something to something else, to something else, to something else. Oh, and then you have this binary. Nice. Poof. So we need to think of this as well. We need to think about these Docker images, because again, just like your dependencies, we blindly count on them. We ask people like, when do you scan your Docker images for operating system vulnerabilities? And 50% says they don't. How do you find out about vulnerabilities in your deployed systems? Well, 45% says I probably won't. Well, let's try something. So you saw this application. Well, I have the same application over here, but as you can see over here, it's running on localhost. Well, it's actually not running on localhost, it's running in a container. And let me show you what the container was. I think, yes, I got it over here. Container is running, but let me go to enlarge it. Docker file. So this is the Docker file. I'm basically doing a multi-stage build using Maven 3 OpenJDK to build it, to do the actual building, and then ship it into a second container, which is a Tomcat container. The Tomcat 8.5.21, because this is an old-fashioned war. I need a Tomcat container. Cool. The thing is that this Tomcat container has an issue. Not my application, the container. It said it was possible to upload a JSP file to the server via a specially crafted request. The JSP could then be requested, and any code it contained would be executed on the server. That sounds good. Exploit database, my favorite database in the world. If I'm going here, this is a Python script, basically, and it does two things. It creates that specially crafted request with two things. It first tries to insert a JSP with this line, basically a println to show that it actually works, if it works or not, just to test it. If that works, we can do the second phase of the attack, which is inserting a form. And because it's JSP, we can execute Java code in it. So that form contains a text box and a button. And if I go into that text box and I write something, if I click that button, it will spin up the runtime, and it will basically execute whatever you put in the text box, giving me myself a web shell. So let's try this. Just to show you that this is real, this doesn't exist, and this doesn't exist yet. So I have loaded this Python script already over here. So let's see if I launch that first attack, it says, okay, it's vulnerable. So that means that my POC.JSP gives all A's. So let's try the second one. Uploading web shell. Cool. Oh yeah, what is the default user for Docker if I don't specify anything? Root. So, nice. Oh, this is different. Oh, maybe I can do something with, well, you understand. I have root access on this thing because you saw the Docker file, and I didn't put it on the internet, but just on my local machine. But I didn't specify a specific user with limited privileges. That's mistake one. Mistake two is I'm counting on an old-fashioned, outdated version of Docker, or of my Docker image. Thing is, I don't have to touch your application, so whatever you did there was perfectly fine. But that might be that application is already in production for so many years, or that container is already built like so long ago. Your container image is vulnerable, so I now attack your container instead of your code. Point is, if I would have scanned this on forehand, I would have known that there were issues with it. For instance, and I scanned it on my local machine, of course with my own tooling, but there are multiple tools available. And it says like you're using a Docker image of Tomcat image 8521, which has over 727 vulnerabilities. But a minor update to 69 in this case would already get rid of a ton of vulnerabilities, and also the one I just showed you. So updating these things and updating your Docker containers and scanning them over and over again is something we need to do. We need to be aware of, because that is something we depend upon as well. So we spoke about code, open source containers, and then we have infrastructure as code. Well, basically Kubernetes or Terraform or whatever you're using to orchestrate whatever you do. One of the misconceptions is that that's on the infrastructure guys. No, it's part of the code base. The Docker container or the Docker image is part of the code base, but also your Kubernetes files. That means if you do misconfigurations in there, like showing some node giving some node too many privileges that it's outward facing, might be harmful. And again, we should be aware of that as well. But due to time, I'm not demoing that. So What is the solution? I showed you a bunch of problems. Well, we already saw that it's not only your code we have to focus on. We have to focus on the layers below that as well, because, again, it's all on our shoulders. We need to do a ton of stuff. But the solution is 3 ways: culture, process, and tooling. And in that order. I'm working for a tooling company, but tooling is not the most important part. Culture is. So let's go into the culture part. What do we mean with culture? Well, we work with different folks. We work with, developers. We'll probably need, the KPIs that we have is delivering stuff, making sure that it's featureful, that it's actually working. Then we have the operations folks. They basically think of, if you think in silos, of course, what happens if it's there, if it works at 3 in the morning and it stops working? Does it automatically scale up? Does it reinitializes? These kind of things. The security folks have, they have one objective: not getting breached. But if we cowboy around and just make sure that whatever is available on Stack Overflow and, hey, it works, fine, ship it, that doesn't align with what security folks need to do. And in the end, we're one team. Think about it the other way. You have a manager, or a program manager, a product manager, breathing down your neck again of that feature. If they don't give you in the end enough time to get rid of your technical debt, then you cannot innovate anymore at the end. Correct? But if we don't do the same thing and think along the lines, not our own in our own cubicle, but think along the lines of the whole system and the whole company, and think along the lines of what security folks need to establish as well, that is one thing. So we need to be aware that security is also our problem. And if that doesn't work, you can just forget it. Stop it. Then you can do tooling, whatever tooling. Tooling doesn't work. If you implement tooling just for the sake of tooling, as a programmer, the first thing I will do is try to circumvent it to see if I can get all tests green and deploy it anyway, even if it's not. And yes, I did that before, and I'm ashamed of it. Then it's process. Don't create new process. Don't create new process like, you need to tick all these boxes and manually test all these things before you can go to production. That only works if you just got breached, and then our focus is on that, but it slightly moves away to your normal way of working, and in the end, it's like, hey, money has power, so if we can ship it again and it makes revenue, we do it. But what about if you look at your current process? How do we work in the current situation? How can we still do that, but make it easier that security doesn't block you, but enables you? So the tooling is pretty much important to your process. Only pick tooling that fits your process. If you don't have a CI pipeline, just for the sake of security, creating a CI pipeline doesn't make sense. But look at your current process, see how it works, and pick your tooling accordingly. Because that is actually tooling. You don't ask a carpenter to just use a specific hammer because he's like, yeah, I'm not using this. This doesn't work for me. Same for you. Pick the tooling correctly. And tooling can help you. But as long as the culture is correct and you look at the tooling from your process perspective. And of course, we can help you. Sneak Code to do the code analysis. I showed you something. Sneak Open Source to do that. Containers to see what kind of base images you have. And infrastructure as code to see if there are things. But again, there are more tools than my tools. The things I showed you are free, by the way. So that's why I'm showing it. And it's not about the vendor or the capabilities of the tool, but it's also when to use it. A lot of folks say we need to shift left, and that means left in this system. Like, on your local machine already do the scanning, like the code scanning while you're working in your IDE, or with a CLI tool on your local machine before it hits your repository. When it hits your repository, it lives there for a certain time. Scan it over there by integrating it with, one of the tools that you like. But say what you want is that if a new pull request comes in, you don't want to get worse, you want to get better, preferably. Then you probably have a CI pipeline, and at a certain point in that time, you might be okay with the amount of vulnerabilities. I'm not saying you have to go to 0, that's your context. I cannot decide for you. Then you go to production. But when you are in production, you're not done, because that's where the biggest mistakes happen, because it's there, let's focus on new features. But what's in production, we need to take care of that as well. So why not monitor that? Take a snapshot, because at that point, your dependencies are static, your base image, we actually know what the base image is, and why not scan that on a daily basis? Because if it's safe now, doesn't mean it doesn't have any vulnerabilities, it's just not yet found. And if it gets found, if it gets disclosed, hopefully in a good way, then you need to get pinged right away so you can make a decision if you want to fix it right away or not. Basically what happens with the whole Log4j thing. The last thing that you need to do is look at your architecture. Are you able, if something like Log4j or Spring Shell or whatever thing, these are all marketing names, but whatever vulnerability comes up, are you able to switch out a library or an image, rebuild it, and instantly release it? If not, then you don't have a security problem, you have an architectural problem. We need to be able to do that constantly in a certain phase. Updating, scanning, and seeing if our application is healthy. But shifting left is not enough, because it's a continuous process. We just heard that waterfall was a thing, it was never meant to be a waterfall. I just heard that there was a text editor that made it a waterfall. But it's a continuous process. Software probably never, like a project never ends if it's in production. You need to maintain it. So not doing it on one stage, like in your CI pipeline or even on your local machine, but do it in every single stage, is what I would say. Make sure that you do it early and often, just like your unit tests. Every build you want to test it. Why not every build to scan your code if there are problems with it, and then actively ignore it if it's not an actual problem, which might happen, or say like, I'm comfortable with it, or actually fix it. So do it on every stage during that cycle so you can fix it early and often. Well, basically, that is what I had to say. Of course, as a good company, I have stickers. If you want some, I've got a pile here. So please, 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 I don't want to take them with me home. And that's it for now. Are there any questions? Are you still asleep? Well, then I want to thank you for your attendance here, and I hope that you enjoy the rest of day 2 of Devoxx and, of course, day 3. Thank you so much.